a little demonstration for you to show you a basic scientific principle. I'm Jason, this is Richard, this is Philip, this is Christian, and Corey is going to be filming us today. So, we were going to do this in your science class, but your science teachers never got back to us. What are you all doing right now in science?
Right on track.
It's really, really hard.
Biosciences. Okay, well, I'm sure you guys are 7th grade, right?
Yeah.
I think next year you're going to start doing some physical science. Definitely, once you get to high school, you will. That's what we're going to do. This is a physics-based. We're going to do conservation of energy, like potential and kinetic energy that you'll get into. So roller coasters, for one. Does everybody like roller coasters?
Yeah.
Yeah. Okay. All right. Does anybody know what a pendulum is?
No.
Big swinging thing. There you go. Absolutely. That's the big. This is what this is. So we're all going to demonstrate, different aspects of that to you, and how kinetic and potential energy basically equal each other. Okay.
All right. So there's two kinds of energy. Well, actually, there's a bunch. We're talking about two today. There's kinetic energy, which is essentially the energy of motion. It relates to how much something weighs and how fast it's moving. The faster it's moving, the more energy it has. So when something is sitting still like this, its kinetic energy is 0 because it's not moving. So if you have a term like you had over here, you had p times 30. If p was, say p was a velocity, and that's 0, then your energy would also be 0. Because 0 times the mass would be 0. So if it's sitting still, it's got no energy at all. When it's moving, it has energy. Energy is constantly changing though. The kinetic energy is going, as it slows down, the kinetic energy is going away. If something is at an elevated position, but not moving, it has what's called potential energy. And essentially, it has the ability to do work if it were released. So in a pendulum situation, as it swings back and forth, when it gets to the top of its arc, it basically stops, changes direction, and comes back. At that point, the potential energy is the highest, because it is the highest distance above its neutral point, which is down here. So essentially what happens is the kinetic energy switches to potential energy at the top, and then switches back to kinetic energy at the bottom. But because potential and kinetic energy transfer back and forth, you can never have more energy than you started with. So if you raise this ball up to here and let it go, it'll never get back to that point, especially when it gets to thin, because the energy is transferred back and forth, and you're going to lose some of the friction. So, see, they're right back up there. Jason's writing the equations on there, sort of.
Oh, they love equations.
Yeah. Especially equations that involve a lot of words. Those are good ones, right?
Oh, those are my favorite.
How do you know?
Well, these are the equations. So we have kinetic energy, energy. That's going to be 1/2 times your mass times your velocity, which is your speed. If you guys don't know velocity, you'll get into that squared. Velocity squared. Your potential energy is going to be your mass times the gravity due to acceleration, and the height, whatever your height your object is going to be at. Roller coaster.
Leading off what Phil said, for our roller coaster, before you release an object, you have your potential energy, which is the beginning height, your mass, and your gravity.
Gravity's constant.
Yeah.
Like you all have gravity acting on you right now.
Then when you release the ball, it can only go as high as you release it. It can't go no higher than that, based off of this principle.
Just catch it so we don't get out of the way. So basically, if we release this ball, this is our little mini roller coaster here. It's going to go up.
And then it falls.
Next ball, yeah. And it falls, yeah.
Just kill me.
So,
They have their helmet on.
alright.
There we go.
Where's the other one? So everybody sees it goes up, it almost comes to the stop at the top, but not quite, and then it continues back down. Do it again here for you. So, roller coasters that you go on at amusement parks, they have the little crank thing that takes you all the way to the top. That's building up your potential energy. Because I mean, you're moving slowly, but the higher you go, the more potential energy you have. You get to the top, it kind of slows down a little bit, and right when it breaks over the top, so as the roller coaster is this ball right here. So right when it's the crank's taking to the top, and then you get up here, and once it drops down, your potential energy is being converted into kinetic energy.
So you want to bring it over to the top rung, show them that it won't go. That's right. And we're going higher.
Just drop some down. And to prove that concept, we'll notice that if you drop the ball from the same height as this one right here, it will never get back up to the top. So if you drop it from right here, you see it stops and it falls off because it never gets back above. Turn sideways. Now you can probably see better. So these two are going to be about the same height right here. If we drop this, it never gets back up to the top. I'm going to raise this up so it's above it. It goes. And of course the roller coasters you go on in amusement parks have twists and turns and loops, and all that's due to the potential energy that you gain by climbing to the top of the hill before it drops down. Does anybody have any questions about anything?
You guys are roller coaster designers?
No, we're students at the university, but one of us maybe in the future.
That's awesome.
You guys go to USF?
Go to USF.
Is that
We
the
don't have
girls?
jobs yet.
Oh yeah, my mom went there. Did they win last night?
I
No.
love
Remember Mr. Hickman's lesson today?
Apparently they lost.
Yeah.
Does anybody know, you ever seen the little desk toy, the little Newton's Cradle desk toy? You
Yeah.
have a ball,
Yeah,
and there's like 5 balls, and then one ball hits, none of these move, and this last one takes off?
Yeah.
Same idea. And then just keeps on going back and forth, and there's not a whole lot of friction in that, so it almost goes on forever, but not quite.
Oh, are you guys gonna like try to make some with loops where if it like goes down, like some like examples?
Are we going to make a roller coaster with loops? You can. There's designs online that you can make a roller coaster that has loops in it, so it just does loop-de-loops.
But the ball would fall.
No, ball wouldn't fall. It
Not
would, if
unless
it had enough energy, enough potential energy, and it came down, it would go around the loop without falling, just like a roller coaster at a music.